So here's a massive, incredibly expensive problem. Every single time you change a drill bit on a rig, you have to unscrew solid steel threads and then crank them back together under a whopping 30,000 foot-pounds of torque. Imagine doing that 40 times per well. Under that kind of extreme, repeating pressure, the metal threads inevitably begin to gall, tear, and basically just die. It's a violent, highly destructive process. The fundamental engineering question we have to ask is, where do you actually want that inevitable destruction to happen? Welcome to this explainer, where we're going to dive into one of the most vital yet totally overlooked components on a drilling rig. Okay, let's dive into this. I want you to make a choice. On one hand, you have a high-precision $30,000 drill collar. On the other hand, you've got a short, cheap piece of throwaway pipe. So, do you want all that extreme wear and tear we just talked about destroying your $30,000 collar? Or would you rather isolate all of that damage onto a cheap piece of pipe that you can literally just toss in the scrap bin when it's ruined? The answer is pretty obvious, right? You absolutely want to wear out the cheap part, not the expensive one. And that exact choice, that core piece of engineering philosophy, takes physical form in a little component called the bit sub. So what exactly is it? Well, a bit sub is essentially a short, thick steel cylinder, usually just 2 to 3 feet long. It sits directly between the drill collar and the drill bit. By the way, the word sub is really just rig shorthand for substitute, meaning it acts as a stand-in or a connector between two other major pieces of equipment. Now to look at it doesn't seem like much, just a heavy chunk of pipe with female box threads cut into both ends. But you know, this simple piece of steel is actually the unsung hero of the bottom hole assembly. It is a deliberate, precisely machined sacrificial connector, put there specifically to take a beating so your expensive drill collars don't have to. Let's break down the specific jobs this short chunk of steel performs down there at the very bottom of the string. First off, it acts as an adapter. The threads on a drill collar and the threads on a drill bit are usually entirely different sizes or types, so the sub bridges that gap. Second, like we established, it absorbs 100% of that brutal make and break wear, but it also earns its keep in a third, absolutely crucial way. Many bit subs are specifically bored out on the inside to house a float valve. This is a one-way check valve that actually stops mud and gas from flowing back up the inside of the drill string when the crew breaks a connection at the surface. So the bit sub isn't just a physical adapter, it literally doubles as a well control component. Now, what's really interesting about this is a major misconception that almost every beginner has. When you screw two massive pieces of drilling pipe together, you'd naturally think the threads are what create the fluid-tight seal, right? Well, actually, wrong. Rotary shouldered connections don't seal on the threads at all. They seal on the flat shoulder faces, those smooth rims at the base of the connection. When you apply torque, those two flat metal shoulders slam together so hard they create a perfect high-pressure seal. The threads, they're really just there to pull those two shoulders into punishingly tight contact. And understanding that distinction is exactly why getting your makeup torque right is basically life or death for the drill string. So the key here is getting that torque perfectly dialed in. A common 6 1/4 inch collar connection requires roughly 25 to 30,000 foot-pounds of makeup torque. I mean, just think about how much force that is. And that number is never, ever guessed. It's not something a driller just feels out, and it's for sure not just as tight as the tongs will go. That specific number comes directly off published API charts, it scales precisely with the connection size, and it is meticulously checked on the rig floor with a calibrated torque gauge. Because if you get this wrong, the consequences are incredibly destructive. Let's walk through exactly what happens if you apply too little torque. Under-torque is, frankly, the silent killer downhole. It happens in a rapid, disastrous sequence. Step 1, you under-torque the connection. Step 2, because it's not tight enough, those flat shoulder faces we talked about fail to create a proper seal. Step 3, highly abrasive drilling mud, under immense pressure, starts jetting sideways through that microscopic gap. And finally, step 4, within just a matter of hours, that escaping mud literally carves a channel straight through the hardened steel. The crews call this a washout. You are essentially using your own drilling mud as a high-pressure water jet cutter against your own equipment. It's crazy. All right, let's test how well you're tracking with this. Imagine you're the driller. You're watching your gauges, and you notice your standpipe pressure has quietly, gradually dropped by 150 psi. You check your pumps, the pump rate is totally unchanged, nothing else looks different on the rig. Take a second and think about this. What is your first suspect? What is that gradual, unexplained pressure drop telling you in drill string language? If you guessed a washout, you hit the nail on the head. Fluid is escaping somewhere it shouldn't, right through that eroded connection we just discussed. Because the system now has an extra hole in it, the overall pressure falls. An unexplained pressure drop is basically the drill string screaming, "I am leaking." And here's where the stakes get incredibly high. If you catch this early, you pull the whole string out of the hole, swap out that single damaged bit sub, and boom, you're back in business. But if you ignore it, that high-pressure mud keeps cutting and cutting until the steel gets so thin that the string physically snaps in half down hole. You lose the bit, you lose the sub, and you just created a massive multi-million-dollar fishing job, all because of one under-torqued connection. And this brilliantly illustrates a concept that actually looks a lot like something you might have sitting on your desk at home. Think about a high-end $2,000 camera lens. If you use filters, you don't screw those filters directly onto the pristine metal threads of the expensive lens 40 times a week. That's a surefire way to ruin a $2,000 piece of glass. Instead, you buy a cheap $10 adapter ring. You wear the threads out on the cheap ring, throw it away, and your expensive lens stays perfect. The bit sub operates on that exact same logic, just scaled up to handle 30,000 foot-pounds of torque instead of just being finger-tight. Now, this isn't just about the bit sub. It's a foundational engineering principle called wear budgeting. And here's the thing a lot of people miss. This idea runs through the entire rig. It's like a giant puzzle where every piece has a specific job. Up on the rig floor, a cheap Kelly Saver sub takes all the connection wear to protect the ultra-expensive Kelly drive. A wear bushing protects the delicate wellhead seals. Brake blocks protect the massive Drawworks flange, and bumper blocks protect the drilling line. Once you spot this pattern, it completely changes how you look at heavy machinery. This one simple rule unlocks the logic of the whole operation. At the end of the day, wear, tear, and extreme friction are entirely inevitable in any heavy industry. You simply cannot stop it. Good design isn't about magically preventing wear. Good engineering is about choosing exactly what gets destroyed. So the next time you look at a massive, complex system, whether it's a drilling rig, a jet engine, or anything else, ask yourself, what is the sacrificial piece in this puzzle? Because finding it tells you exactly what they couldn't afford to lose. Pretty cool, right?